Okay. We are going to be discussing an essay on neuromuscular transmission. Now, for this essay here, it was asked in MB1 of the receipt of December 2025 and MB1 of May January 24. So it's very necessary you have an outline as you write your physio essays. And an outline that can help you is one that has a definition, one that has a diagram, that has the anatomy of the neuromuscular junction, and that neuromuscular junction should have a presynaptic, should have a synaptic cleft, should have a postsynaptic. It should also tell us the mode of transmission, and this happens to be where the bulk of the mark will be. Then we'll talk about the fate of acetylcholine. We'll talk about the properties of end plate potential, miniature end plate potential, and then clinicals. But for clinicals here, I'll dedicate a separate video discussing them in detail because these are short note questions necessary for your exams. Now, what is the definition of neuromuscular transmission or the neuromuscular junction? It is that communication between a neuron and a muscle fiber, a neuron and a muscle fiber. And with the release of a neurotransmitter, for the sole purpose of muscle contraction. What a beautiful way to make an introduction or define that neuromuscular transmission happens to be the communication between a neuron and a muscle fiber with the release of a neurotransmitter for the sole purpose of muscle contraction. Now, your diagram should have these three components. The diagram should have these three components. What are the things the diagram should have? It should have a portion number one. This is the presynaptic terminal. It should also have the synapse or the gap there, and then it should have the muscle component itself. So this is the muscle component or the postsynaptic fiber. This is the presynaptic fiber, and then this is synaptic cleft. Now, next things next, this has myelin sheath like that. And then it also has some channels. These channels are called the calcium channels. These are calcium channels. Okay, on this portion here, we're also going to have different vesicles for the storage of acetylcholine. Okay, so what have I said? I have a presynaptic terminal that has calcium channels for influx of calcium. These are myelin sheath. This is the presynaptic terminal. These are vesicles. And then we have said this space is the synaptic cleft. This is the muscle unit or the postsynaptic fiber. So that is quite necessary for the diagram, quite illustrated. Now let's begin with important points to note for the presynaptic. What will you say in the presynaptic? Number one, it is that part that should have myelin. You are going to outline that it is highly myelinated. Number two, it should be the part that has calcium channels. You highlight that it has calcium channels. Number three, it is rich in what? In vesicles. It is rich in vesicles that are loaded with acetylcholine. So those are important things to note in the presynaptic. So in the presynaptic, if you have to write, you say number one, it has myelins. Number two, it should have some calcium channels. Number three, it should have vesicles. Now, what else will you talk about in the synaptic cleft? In the synaptic cleft, which happens to be this portion, two things you can say. You are going to say, number one, it is that portion that has a diameter of 20 to 30 nanometer wide. So the gap in this portion here is 20 to 30 nanometer wide. Secondly, it has a particular enzyme. That enzyme is called cholinesterase. All right, so we have talked about what you can see as features of the anatomy of the presynaptic, what you can see as features of the anatomy of the synaptic cleft, and features we are going to see in the postsynaptic cleft. Number one, it should have some receptors like this. And these receptors are called nicotinic receptors. Now, actually, it is these nicotinic receptors where acetylcholine binds. Two acetylcholine binds for each one. So acetylcholine binds here. So it's necessary you have that in mind, that nicotinic receptors are present in the postsynaptic for the binding of two molecules of acetylcholine. Now, what else do we take note again of the postsynaptic is that these channels, these receptors are coupled with sodium gated channels. Sodium gated channels. So also take note of that. It is coupled with sodium gated channels. Coupled with sodium gated channels. All right. So we have been able to highlight the most important facts for the anatomy, presynaptic, synaptic, and post, and then highlighting some of the major things that can be seen there. Now, how about the mode of transmission? Now, for the mode of transmission, I'm going to highlight all the points sequentially. Number one point in the mode of transmission is that action potential must come and reach the end of the presynaptic terminal. So, action potential must travel. Action potential will travel. Now, if action potential travel till we reach here, what will be the interpretation? Interpretation must be that we must open channels of calcium so that it will help for the eventual release of acetylcholine into this space. So number two, calcium channels will open, calcium channels open, and there is influx. There is an influx, okay? An increase in influx. Now, what's number three thing that happens? So number one, action potential reaches the ends of the presynaptic terminal. What is number two? Calcium channels open for the influx of calcium. What is number three? These calcium that has influx will then arrange these vesicles so that vesicles will eventually bind to membrane for the release of their substances by exocytosis. So number three, the release of acetylcholine from vesicles via a particular mechanism called exocytosis. Now, it is quite necessary you add this point that we have about 60 vesicles, and in each vesicles, we have about 10,000 molecules of acetylcholine. Now, what do we say as the fifth point? The fifth point you are going to say is that these acetylcholine that binds are going to bind to each receptors. And once they bind to each receptors, they are going to cause, so acetylcholine binds to which receptors? Acetylcholine binds to nicotinic receptor. That's the fifth point. What's the sixth point you will make? This is going to cause influx of sodium. And influx of sodium will cause the generation of miniature end plate potential and eventually end plate potential. All right, so I can recap all the points again. What are the 6 points for the mode of transmission? Number one, we have action potential reach. Number two, influx of calcium. Number three, vesicles should bind to membrane for the release of its content by exocytosis. Number four, we have about 60 vesicles, and in each it contains 10,000 acetylcholine. Number five, acetylcholine binds to nicotinic receptors. And then number six, influx of sodium, creation of miniature end plates, and then end plate potential. Now, the next thing is the fate of acetylcholine. I really do hope you are following me. Now, for the fate of acetylcholine, first things first that you say is that acetylcholine only spends about 1 to 2 milliseconds in that cleft. Only 1 to 2 milliseconds in this cleft. That's number one. Then number two is that acetylcholine must be broken down by an enzyme called cholinesterase. So cholinesterase breaks it down into two things, acetyl unit and choline. And then you are going to say that these two are going to be reuptaked. They are going to be reuptaked back here like this. And then you reuse again. So those are the three things you will talk about in the field. See, number one, acetylcholine only spends about 1 to 2 milliseconds here and must be broken down by the enzyme cholinesterase, and the resultant acetic acid or acetyl unit and choline is then reuptaked back into the presynaptic terminal. Now, what about the properties of end plate potential? Properties of end plate potential, number one, is that one presynaptic always makes communication with one muscle fiber. Yes, so that's number one property, that one presynaptic must always make communication with one muscle fiber. What's number two characteristic? Number two characteristic is that in this generation, it is always excitatory. Never is it an inhibitory kind of potential. It is always excitatory. Number 3 is that the potential that we see in EPP is usually about 3 to 5 times more than threshold. 3 to 5 times more than threshold, meaning it has a safety value. And then number 4 point is that there are some drugs that can prevent the generation of EPP. Such drugs, examples, we have the likes of curare, we have the likes of physiostigmine, okay, we have the likes of neostigmine, and the list goes on and on. So please take note of that. So in the properties, we say number 1, one presynaptic, one postsynaptic, or one presynaptic, one post. Number 2, it's always excitatory, never is it inhibitory. Number 3, end plate potential is about 3 to 5 times more than the threshold, meaning it has a safety value. Number 4, drugs that can prevent the production of EPP are like curare, like physiostigmine, like neostigmine. Now, what are the things you talk about in miniature end plate potential? You will see miniature end plate potential happens to be that early potential that is made, the early potential that is made when sodium influx, when sodium begins to influx. So that's the first point you will see. Now, another thing again you will say is that it has an amplitude of 0.5 to 1 millivolt. Another thing again you will say is that its potential can be increased by calcium or can be decreased by magnesium. So please take note. So miniature end plate potential, again, the amplitude is 0.5 to 1 millivolt. It is increased by calcium, it is decreased by magnesium. And we say it is that early potential that is formed when sodium started what? Trickling in or influx. All right. So for the clinicals, I will discuss each of them later in a separate video, which I'll tag here. But what do we remember from myasthenia gravis? Myasthenia gravis happens to be when nicotinic receptors are blocked, while Lambert-Eaton happens to be when calcium channels are blocked. Okay, so just note that. I will talk about them again in detail. So if you have watched to these points, I really do hope you made sense from this essay and you can be able to replicate it if you get to see this question in your next exam. Do have a wonderful time. Thank you.